All righty. So today I'm welcoming you to MCAT Science Prep. We're looking at SIRS or science question types. So that is our goal, and we'll be looking at quite a few different ways to tackle science questions. The reason I'd like to look at science question types in a very distinct way from CARS question types is because in science, there's actually a lot of unique ways to approach the questions. If you're looking for patterns, you will find patterns, and you'll find ways to like tackle a question, even if it looks unfamiliar. So basically, these are ways to dig into the question, even if you don't know exactly what's going on, and like at least give you a foothold so you can eliminate some answers and possibly even eliminate down to the correct answer sometimes. So let's get started. So really, there's just a plethora of different strategies I could come up with. Try to stick with ones that I find happen the most often. And I encourage you guys to actually look for your own strategies. Like something I always have my own students do when I'm tutoring them is have a piece of paper that you keep with you while you're studying and reviewing tests. And on that piece of paper, when you notice that you see some patterns in the way answers are structured, the way a question is asked, write that down on that piece of paper, and then keep that with you while you're taking or doing practice tests or practice questions, so that you start to use the strategies. One of the things is it doesn't help if you know strategies. If you're not using them when you're practicing, you're not going to get better at it. So for the time being, just put it right there next to you and like say, oh, that's that kind of question. Let me try the strategy on that question. You've got to try the strategies in order for them to work. The first one I want to look at is these term questions. You'll see them quite a bit. It's basically a question and it throws down a whole bunch of different terms. They're usually 1-word or 2-word answers, and they're pretty straightforward to tackle. And the thing I like to think of these of is usually they're like Sesame Street type questions. Like which one of these is not like the others? Which one of these is not the same? Which one of these is not the others? Come and play my game. So like do that on this question. If the question is enzymes catalyze chemical reactions by stabilizing blank, which one of these 4 answer choices doesn't belong? Yeah, D for sure doesn't match the question. First off, you can't stabilize an equilibrium. But the other 3 terms, substrate, product, transition state, they all make sense in comparison to other. In context, you're looking at a reaction map and it says like the substrate is the reactant, the product is the product, and that peak is the transition state. So get rid of those oddball terms right away. Now, I will say that sometimes the oddball term is the correct answer in a sense because none of the others work. So that's why I like to think of the Sesame Street answer as being the one that's either really, really right or really, really wrong. In this case, I'm looking at this going like the equilibrium, that's really, really wrong for this question, so get rid of it. Then just address each and every remaining answer choice and eliminate bad answers. So do enzymes stabilize the substrate? No, then the reaction would never happen. That would be a bad choice. Do they stabilize the product? No, then the reverse reaction would never happen. And we know enzymes do reversible reaction stuff. It's always associated with that. And do they stabilize the transition state? Well, if that's our last answer standing, it must be the correct one. And yes, in fact, they stabilize the transition state, or they lower the activation barrier between the substrate and the product, all kinds of different ways to think about it. But get rid of those silly answers first and then start taking them one at a time. Always address every answer choice. Let me ask that as a quiz. How, like, do you, let me try it again. I screwed it. I'm just going to say it. I lost my train of thought. Always address every answer choice. Never leave anything to the wind. Never just jump to the straight answer. Always use POE. What does POE stand for? Everybody, Put that one in there. Everybody want to hear this process of. I like prices of elimination. Process of elimination. Process of elimination. It will be your best friend in the whole world. I like to think of it like if you're trying to find the answer choice you like, you will dismiss all the things that are bad about it because you like it. Just like that relationship you've once had, or might be in, I don't know, that everybody's had a relationship in their life where they can't stand the person, but they'll say like, I can fix them. I can make that a better person for me. I'm not going to break up with them. You don't want to fall in love with an answer choice. You want to find all the flaws and tear down the answer choices because of their flaws. All right. Least not accept questions. Least not accept questions. They always put that word in capitals, least not or accept. There's other ways they can kind of come up with these kinds of questions. But for the most part, it's going to be not or least not or accept in them. So I don't fall for traps on these questions. I actually approach them in a different way. And I think it's a good idea to do that. Because what's the temptation? Is A good answer or a bad answer? Phospholipid, is that a good answer or a bad answer for this question? It's a bad answer. However, if you're on autopilot, is it a good answer or a bad answer? It looks like a good answer. Because if you're on autopilot, you come into the question, you're like, which type of molecule is likely to be found in a eukaryotic cell membrane? Phospholipids, done, moving on. Oh, you just fell for the trap. So I always cross out the least not accept. I will actually strike out that word. So it just says which type of molecule is likely to be found in a eukaryotic cell membrane. And I'm going to true false the answers without that word. So phospholipid, is that true if I take away the least? Yes. Is cholesterol true if I take out the least? Yes. Is glycoprotein true if I take out the least? Yep. And peptidoglycan, is it true if I take out the least? There's my false one. And I do this on my scratch board. I like have A, B, C, D written down on my scratch board. I will put a T or an F next to each of them. And then once I get down to the answer, just pick, or once I get done with my labeling, just pick the one that's false. That must be the correct answer. Is it a little extra work? Yes. But remember, you're not necessarily thinking in your right mind, and you need to slow yourself down on these questions just a little bit in order to be more successful. So this is my least not accept strategy that makes me treat these questions uniquely. All right. Oh, math. Oh, yuck. Do we have to do math on the MCAT? Yes, we do. Do we get a calculator on the MCAT? Is that something you guys have access to on the MCAT? Nope. You have to do math without a calculator, which means you have to learn a few strategies for doing the math without a calculator. And people often will look at pH questions and go like, logs? I can't do logs without a calculator. Yeah, you can. There's plenty of ways to do logs without a calculator. You just got to learn them. But sometimes we don't have to do that. We could, on a math question, eliminate some answer choices. And this one's an excellent example of it because we can ballpark. We can ballpark our answers. This question is asking, what is the pH of a 0.1 molar solution of sodium acetate? So, sodium acetate, is it an acid or is it a base? It's a base. Considering they started the thing out saying acetic acid, I know acetic acid is an acid, which means its conjugate is a base. Mind you, that is a trap in this question, but we know we're looking for the pH of a base. Which two answers cannot be correct? Just absolutely cannot be correct for this question, if that is a base. The pH cannot be 7. The pH cannot be 2.9 if this is a solution of base. Didn't have to do any math to do that. Then, is this a strong base or is this a weak base? And in your studying, you should have a good idea of what the strong bases are. Is this one of them? This is a weak base. The conjugate of a weak acid is a weak base. It's a strong conjugate base, but it's a weak base. So if it's a weak base, are we going to have an extreme pH like 13? Or are we going to have a reasonable pH of 8.9? Yeah, this is not going to be 13. This is going to be 8.9. Without having to do any math. Holy cow, is it that easy? Yes. So don't lose out points because you're not ballparking. Don't try to force yourself to do math if you're not comfortable with the math. Use common sense. Use what you know about the properties of pH or properties of whatever the problem is about to eliminate bad answer choices again. We can tackle math questions a lot of the time, never doing any actual math. Now, I know I always get somebody that asks, how would I do this regular? The pH of a weak base is negative 1/2 the log of the Kb times the weak base concentration. So I'd have to come in here and go, okay, this is negative 1/2 the log of, well, the Kb is going to be 10 to the minus, let's see, 10 to the minus 9.2, and my weak base concentration is 10 to the minus 1. So that's going to be what, 10 to the minus 10-ish. So negative 1/2 the log of 10 to the minus 10. Oops. Which is going to give me negative 1/2 of negative 10 or about 5. But that's actually the POH. So what's my pH? How do I find pH from POH? pH plus POH equals 14. So if I know the POH is 5, what does my pH have to be? It's got to be 9. 9 plus 5 is 14. And wait, there we go. 8.9, that's close to 9. Has anybody ever seen that equation I used for POH of a weak base before? What? Samantha, where did you see that? Most teachers never teach that, because I'm going to guess, has anybody else ever seen that equation before? Anybody else? I want to get a gauge on the class here. Everybody answer. No? Okay. So I'm going to take that as to mean 3 no's means probably most people haven't. These two equations I would add into your equation list to know. pH of weak acid is negative 1/2 the log of the Ka times the weak acid concentration. Kb, or sorry, POH of a weak base is negative 1/2 the log of Kb times the weak base concentration. And what these are is basically an already solved out version of an ICE table. You guys remember those wonderful little ICE tables? You didn't have to actually do that ICE table over and over and over and over again. You could have just used these two equations. So make sure you know these. It's going to make these questions not require ICE tables if they were more complicated than this one. Already got that? Give me a thumbs up if you got it. Tricks of the trade, man. Tricks of the trade. All righty. So what other kind of math problems? Oh my goodness. How do we do fast math? So don't try to do everything all at once. That's a big mistake. Don't do everything at once. Round the bejeebers out of numbers, man. Just round it. I don't care what the number is, round it. And then cancel before you multiply. What's that again? Cancel before I do what? Cancel before I multiply. Why? Well, multiply makes numbers bigger and harder to work with. Division makes numbers smaller and easier to work with. So cancel before you multiply. And don't be afraid of fractions. Fast math is all about fractions. So here's a question saying the mean molecular weight of an amino acid residue is 110 grams per mole. Protein has a mass of approximately 50 kilodaltons. How many amino acid residues are in the protein? So what is the mass of 50 kilodaltons? What is that in grams per mole? Remember, a dalton is equivalent to a gram per mole. So how many grams per mole is 50 kilodaltons? Kilo. How many meters in it? There, it's okay. It's kilos 1,000. So if I've got 50 kilodaltons, then how many daltons do I have? How many grams per mole do I have? I think there's too much thinking going on in this question. There we go. 50,000 daltons. Yeah. 50,000. So 50 kilo is 1, 2, 3 more zeros. So I got 50,000 daltons, which again is equivalent to a gram per mole. And I have a feeling that's the sticky point right now is people don't remember that dalton and gram per mole are equivalent units. So if I have 50 daltons or 50,000 daltons, and I want to find out how many amino acid residues there are, or moles of amino acid residues there are, what am I going to divide this by? What is the mass per mole of an amino acid? (110 grams per mole). So I can divide by 110. Do I want to divide by 110? Is that going to be fast math? No. What am I going to divide by? I just got to be close. I don't got to be precise. I'm just going to divide by 100 daltons, which is equivalent to a gram per mole. And voila, what's my answer? Cancel, cancel. There goes a 0. There goes a 0. And I'm left with what? (500 amino acids. So what is the answer? 250, 450, or 5,500? Yep, it's going to be C. So you do not have to get the exact answer. You have to be okay with that. And I think the biggest problem people have with doing fast math is that you will not get the correct answer. You're going to get close to the correct answer. You're going to be rounding. And that's the only way to be able to do this, because I don't expect anybody to be doing long division with 50,000 divided by 110. In fact, what does that even give us? 50,000 divided by 110 gives us 454. Even that doesn't give us the exact answer. It gives us 454. So since they're using approximate and rounding and stuff, it's all good. That brings up another point. What's pi? Not on this test, it ain't. 3. It's just 3. Use 3. What is the speed of light? Yeah, we don't want to do that 2.998 crap. It's just 3 times 10 to the 8th meters per second. What's the gravitational constant? G. Now we got it. 10. 10's a lot easier to use than 9. We can just say, because 9.8 makes 10. That's close enough for rock and roll. Like, so even your constants, just memorize them to one digit. You do not have an equation sheet. You have to know your constants. You have to know your equations. That's a good question. And when you're learning constants, though, don't memorize 27 digits. One digit is more than enough to do the math you're going to do on the MCAT. Roman numeral questions are always fun. You see these from time to time. They used to be more common than they are now, but you still can have a nice time with these. I know it's really weird. So looking at this, what Roman numeral do you guys want to attack first? Roman numeral 1, 2, or 3? Why 1? Why number 1? Does anybody disagree? Okay. So it's easier if you go in order. That is not necessarily true if you go in order. In some cases, they will intentionally make in order harder because they're going to put the harder things as Roman numeral 1 because they know people like you exist, which want to go through because in order. Okay, we got a person says 2. Why 2? Because it shows up 3 times, Celestia? Well, that probably means it's true. So that's not a good elimination tactic because then you're going to only get to eliminate one answer choice. Anybody here want to go after the Roman numeral that shows up only once? Because that one's probably false. And so therefore you'll only eliminate one answer choice. Always go after Roman numerals if they appear twice first. Because what am I guaranteed to do? I'm guaranteed to eliminate how many answer choices? I'm guaranteed to eliminate 2 answer choices, right? That is a smarter way to go. And if it does that, then you're only going to have to look at 2 of the Roman numerals. That's less time invested into a question. So I would actually start on Roman numeral 1 or 3 here, but since I set up the slides looking at 1 first, I'll just go and look at 1. So we're looking for has the same carbon-oxygen bond order, but a longer bond length than carbon dioxide. So what kind of bond order does carbon monoxide have? Is it a single or double or a triple bond? It's a triple bond. What kind of bonds do we have in carbon dioxide? Double bonds. So Roman numeral 1 is in or out as an answer. It's out, which means which answer choices can I eliminate? A and D go bye-bye. And fancy that, formaldehyde, do I even have to address it? Nope, because 2 is in both remaining answer choices. I know it must be true, correct. So therefore, I'm going to go after Roman numeral 3. So carbonate. Does carbonate have the same bond length or bond order as carbon dioxide? So what's the bond CO bond length in carbon dioxide, or sorry, bond order in carbon dioxide? Dang it. Try again. What's the bond order in carbonate? What's the bond order in carbonate? Because we already know carbon dioxide's 2. Is it just a double bond? Or is it a fractional bond length because we have resonance? Exactly. There's resonance. We've got 4 bonds split out over 3 spots. So the bond order of this thing is actually 1.3. So does 3 work as an answer for this one? No. So what's my best answer then? It ain't C, so it must be B. There we go. There's our answer. So go after the Roman numeral that shows up twice. That's the most efficient way to attack these questions. Now, sometimes there's no Roman numeral that shows up 3 times, so then it's whatever, whichever one's easiest. Pathways. They got a few of these pathways questions nowadays where they like say, okay, which of the following best describes the pathway for something happening, blah, 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 blah. I always tend to do look for the same things. First thing I do is I verify the endpoints of the pathway. So do any of these things have a weird endpoint? Like they all have nucleus, so the beginning point's fine, but any of them have like a strange endpoint that doesn't make any sense? We're going to produce a plasma membrane bound protein. No, B makes perfect sense. Because for it to be part of the plasma membrane, it has to be released from the interior of the cell via a secretory vessel, an exosome, if you will. So if B is okay, which one is the bad one? Which one's going opposite, has like something opposite direction in it? No, D's okay. D's going the right direction. Nucleus to cytoplasm, rough ER. No, that's okay. Nucleus to cytoplasm, it gets synthesized at the ribosome, and then it gets sent to the rough ER, and then it goes to the Golgi apparatus. Methinks we don't know what an endosome is. What is an endosome? Is it something that helps exocytosis or endocytosis? It does endocytosis. That is not what we're going to be doing here. We're not bringing something into the cell. We're sending something out of the cell, essentially. Membrane bound is essentially out of the cell. So that one's got a weird endpoint. So did you notice what I called a secretory vesicle, though? What did I call a secretory vesicle? An exosome. So for all intents and purposes, they're opposite things. Endosome brings stuff in, secretory vessels pump stuff out. And at the end of the day, a membrane-bound protein is leaving the cell mostly. It's heading out into the extracellular environment. So that's one thing I would look for as endpoint weirdness. Look for reversals. We got rid of that reversal with that endosome as well. Look for gaps in the pathway. Are there any just major league gaps in this pathway? We're starting with mRNA and we're making a protein. D's got some gaps. Nucleus to cytoplasm, rough ER. There's something missing between cytoplasm and rough ER. What has to happen to the mRNA before it can go to the rough ER? For whatever it can go to the rough ER. Remember, we're starting with mRNA to make what? To make a protein. How do you turn mRNA into a protein? Got to translate. Where does translation happen? Ribosome. There we go. So we got a gap here because we're going straight from the nucleus to the rough ER, or straight, I mean, that's not too big of a gap except for the ribosome's missing. Cytoplasm, that's more complete, but it's still missing the ribosome. We got to have that ribosome to do this whole process. So at the end of the day, boom, there's our answer. So now one of the interesting things is Golgi, that's not the endpoint. But once it gets to the Golgi, it can continue on. So it doesn't have to be a perfect answer. It's just got to be better than the rest. It's got to be better than the rest. We need those ribosomes to do some work there. So these are tricky. These are tricky questions sometimes because they leave out key things and you have to think about the entire process. Up next, the most common question type the most common question type on the MCAT, the 2x2. And I'm sure you've seen these in your studies so far. They're basically giving your answer choices, which are combinations of two different things. Like in this case, it's uni versus multimodal and top-down versus bottom-up processing. Only deal with half the answer at once. If half the answer is wrong, then what must be true? If half the answer is wrong, then the entire answer is wrong. So I don't have to deal with all of it. So let's deal with the stimuli first in this Where's Waldo example. In the classic series of blah, 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 Where's Waldo? We're looking at a huge colorful image, looking for a particular character wearing red and white. This exercise represents what sort of censoring process is being set up. So what sense am I using to look for Waldo? Am I using one sense or multiple senses? One sense, I'm using vision. Unless you suffer from synesthesia, then you might be using multiple senses, but you always should assume that this is a standard neurotypical individual when doing psych-soc questions. I mean, that is a good point to make. When answering questions such as these, always assume neurotypical unless otherwise stated. So somebody that has synesthesia might actually be doing this multimodally, but this is a unimodal stimuli that we're using. We're using vision. And then are we using top-down or bottom-up processing? Are we starting at the small scale and looking for the whole scale, or are we starting with the big scale and looking down to the small scale? How big is Waldo compared to the book, or compared to the picture? Waldo's tiny. So we're going from big scale down to small scale. What kind of processing is that? That's top-down processing because we're faced with all this information and we have to cut away all that other information down to these smaller things. That's top-down processing. So my final answer must be A because I can get rid of the bottom-up processing answers. You could have answered this in the opposite direction as well. This is a good example of a common 2x2 setup in psych-soc. So you'd have to be thinking about your how you not interpret things, but get information in your brain and use that information. And there you go. So 2x2 is very common, so much so that I've got several strategies around it. There's also these kind that I like to call 2x4s. So they have like, and this one we can't answer straight away because it says based on the passage, but I just wanted to put something like this in here because if they bring a judgment call into it, I call these 2x4s. What do you notice about the answer choices? The first half is no, no, yes, yes. The second half is it a two things compared or four things compared? It's four things. That's thus the 2x4. It's tempting to eliminate yes, yes, no, no, or no, no, yes, yes, or whatever, agree, disagree if it's cars. It's tempting to do those first. Don't do those first, because that means you have to make a judgment call and your judgment might be flawed because you don't know all the information. I always suggest you start with the fact, prove or disprove the fact before you go after the yes, yes, no, no. In almost 100% of the cases, based on the fact alone, you will be able to eliminate down to the correct answer. You do not need to make that judgment call. Judgment calls are hard. So have you guys seen this in other ways on MCAT questions besides yes, yes, no, no? You see these a lot in cars too, by the way. Judgments are like yes, no, or strengthen, strengthen, weaken, weaken, or agree, agree, disagree, disagree, or like anything like that. It is going to be the 2x4 type strategy. And again, with the 2x2s, they also show up in questions like this, which I call, these are 2x2s, but I call them mapping questions. Because look at those answers. What makes those answers hard to deal with? What makes those answers hard to deal with? Even though it's a very simple question. Yeah, they look the same, except they're just moving words around, right? So all they've done is kind of swapped out one word for another and just changed the direction. So if you're not careful, they all look the same. So anticipate this and do what I call mapping. So in the first statement, it's got actin, pull on myosin, actin, myosin, myosin, actin, myosin. So I just mapped it in my scratch board and said, actin is pulling, myosin, myosin. I just jotted that down so I could keep the answer straight. And then the second part is closer to the edge, closer to the center, closer to the edge, closer to the center. So now I've got this mapped out on my scratch board. I'm less likely to misinterpret reading those answers over and over and over again. So now we can attack this like we do any 2x2 and just say, okay, is actin pulling or is myosin pulling in a skeletal muscle contraction? What does the pulling, actin or myosin? So I can get rid of my two actin answers, bam, bam, and I'm left with myosin. And then are the edges of the centromere brought closer to the center? Or sorry, are the myosin filaments being pulled closer to the center or pulled closer to the edges when they do this? Remember, the sarcomere gets shrunk smaller, so it's pulled towards the center. And therefore, my best answer is answer choice D. Oops, answer choice D. There we go. So it's easier to tackle when you're not trying to reread the same word soup over and over and over and over and over again. And that's what I call it, is just word soup. Don't get involved in it. Another one. This seems like it'd be a very limited use technique, but you'd be surprised how many questions are like half-life. Sometimes it's just worth bucking up and writing out a table. Don't be smart. Don't try to apply equations if you don't know the equation, because the equation here has a log in it, and like you're not going to want to do that. Just make a table, man. Just create a table. In that table, put time and quantity. Start at time 0, put the original quantity, 9,600. And then every timestamp, every half-life, and notice what I'm doing here. What kind of math am I doing here? Am I rounding or using exact numbers? I'm rounding the bejeebers out of it. So 12, exactly, I'm doing fast math. So I got 0, then 12, then 24, then 36. I'm ignoring that 0.32. Then I go 9,600. And finally, once I get down to like 150, or sorry, not 75, I halved it and I did 38, because that's not really half, but it's close enough for rock and roll. And then 19, and then 9, then 5, then 3, then 2, then 1. And 1 comes around 168. So what's my best answer? It's going to be C. It's not exact, but it's close enough for rock and roll. And the way they do these questions, they will always set them up so that it's pretty clear what answer is going to be it. They don't, like, they're doing the math in the table to create the answer choices. So keep it simple. If there's ever a time to take some time to do this, this is well worth the time. Like, a lot of people won't do this because they think it's just wasting time. but you know what you're doing. You're going to get to the answer. It's worth the time investment. You will get it right. Period. That's a good enough reason to do it. Trend questions. Trend questions. This could be periodic trends. This could be trends like they're introducing something new here. One of the first things to do is eliminate the answers that put the extremes in the middle. So looking at P, Q, and R, the data that we're given, which answers have an extreme smack dab in the middle? B and D. Wait, no, not B and D. Which one's the extreme? Look carefully at the numbers. Look carefully at the numbers. They're not in order. Wait a minute, you're right. I'm an idiot. Sorry. I'm going to blame this on being tired. Turn that frown upside down, make it a smile, because you're right. B and D. I don't know what I was thinking. Oh my goodness. For whatever reason, I was thinking R shouldn't be in the middle, but it better be in the middle because that is in fact the one in the middle. Sorry about that, Sana. Does everybody see that? That R is smack dab in the middle of the trend. It has to be in the middle of the trend. P and Q have to be the extremes. And why do they do this? Why is it that the answer choice is almost always one of the opposite answer choices, which it is? It's almost 100% of the time one of the opposite answer choices. What do people always do wrong on these questions? I'm sure everybody's experienced this at some point with a ranking question. Greater than versus less, maybe not even that, but I think it's even as fundamental as looking at the answer choices, greater than versus less than, right? Greater than versus less than. I'm sure at some point you ranked it correctly, but then interpreted the greater than, less than signs incorrectly. Oh, that sucks. So now, once we've done that, we have to figure out what the relationship is. So using the information in this question, is current directly related or indirectly related to wavelength? Or, yeah. There's a stair step concept in the middle because they tell us how current is related to what in the question. Moving electrons, that is the current, is what to energy, or is directly proportional to what? To energy. So they're telling us that current is directly related to energy. There's my connection. If current is directly related to energy, how is energy related to wavelength? As the energy goes up, the wavelength goes down. So what's the answer to this question? Is it A or is it C? My highest current has the highest energy. It should have the shortest wavelength. So my answer's got to be A. It's got to have that shortest wavelength. So ranking questions, always an interesting question. And also, like, you'll see a lot of questions, well, not a lot, but you'll see questions that rank F to Cl to Br to I. Which two halogens will never be in the middle? F, Cl, Br, I. Which two will never be in the middle? Oh my. Oh my. Let's throw some chemistry on you. F, Cl, Br, I. You just need to know this. You just got to know this. This is the one column in the periodic table I am telling you guys to memorize. FClBrI. You will never see F, you'll never see fluorine, you'll never see iodine in the middle. It will always be chlorine and bromine. Always, 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 always. Another very important chemical trend, because they do ask periodic trend questions quite a bit, Funkelbritish. Anybody heard of that mnemonic device before? Funkelbritish. It's the order of it's the decreasing order of electronegativity from highest to ninth highest in the case of hydrogen. Funkelbritish. FONCLBRISH. So use this to remember order of electronegativity, because looking at the periodic table doesn't get it this precise for you. It doesn't get it this precise for you. And you do need to be able to judge the electronegativity in that little corner like that. All right, so we've seen a lot of question types today, all these different types, pathways, Roman numerals, but there's just so many more. And I'm going to put a task on you guys. Whenever you're looking at practice problems, I want you to actively be looking for different question types that you may have discovered. Then add them. Tell me about them, because I steal them. I love collecting stuff like this up and putting it out there for other students to use. Because if you can look at a question and say, it's this kind of question, well, you feel more or less confident, even if you don't understand the content. You recognize the strategy, even if you don't know the content, you're going to feel more empowered or less empowered. More empowered. That's the whole goal behind all this, right? Even if you don't have a clue what's going on in the question, you at least can eliminate some answer choices. And if you had to guess, your guess is probably going to be better than it would have been just guessing wildly. So strategies, that's what it's all about. Just going into this thing like, yeah, I got a way to attack this question. I don't know what I'm doing, but I know how to attack it. That's fine. That's perfectly okay. Fake it till you make it. That's my rule. Worked for me 47 years. It's going to work for another, I don't know how old I'm going to get to, maybe another 20 years. All right. Next session is we're going to be doing CARS passage strategy. And the one after that, we're going to be science passage strategy, how to tackle the passages, how to get in there and read fast enough or not read as far as the case may be. We're going to do that one on July 27th, so 2 weeks from last Tuesday. The mock test is coming. I've seen many of you guys have signed up. I'm going to send out initial information this Friday to get signed up for an account to take that test. And then I'll just be sending out reminders as we get closer to the test. So there will be information coming there. You can always come to drop-in office hours on Monday mornings, Monday from 8 to 12 or 8 to noon, if you want to say it that way. Otherwise, ask me some questions. Thank you all for coming by tonight. I hope you learned a little bit about how to tackle some science questions.